Hi everyone, welcome you all to the Brilliant group of institution. Here we are continuing the most important MCQ from the chapter Alcohol, Phenols and Ethers. Alright, so let's go to the question number 1. Here we have the question, phenol on distillation with zinc dust gives. Phenol on distillation with the zinc dust. Alright, so what's the reaction? You know phenol, this is the compound called phenol. It's treating with zinc dust, right? Zinc dust. You know, zinc is a reducing one, right? It's a reducing agent. So zinc, it will replace this oxygen atom, or zinc is removed as which one? Zinc oxide. Zinc is a reducing agent. So zinc, which is removing that oxygen atom. So what is happening? Your product is what? Benzene, right? Your product is benzene. This is nothing but reduction of phenol. Phenol on reduction, we will get benzene as a compound. So what's your answer? Option C is the correct answer. All right. Question number 2, we have the process of converting a alkyl halide into alcohol involves dash process. Whether it is a substitution, addition, rearrangement or dehydrohalogenation. That's a question. Alright. So process of converting a alkyl halide. Let me take one of the example of alkyl halide. For example, CH3Cl, methyl chloride. This is a haloalkane into alcohol, right? Into alcohol. For example, methanol. Methyl chloride, we can convert it into methanol by what reaction? That's a question, right? Here we have chlorine, we are substitute, or chlorine we are replacing, we are substituting OH group. You know how to convert a haloalkane into alcohol? Very simple method. We can use aqueous KOH, right? Aqueous KOH. What is happening here? Halogen is leaving, OH minus, this is the OH minus, K plus and OH minus. K plus Cl is eliminated as KCl. Instead of chlorine, OH minus is substituting. What it is called? One species is leaving and the other species, especially a nucleophile, right? OH minus is the nucleophile here. It is substituting. So what is the reaction here? We can call it as, it is a substitution reaction. It is a substitution reaction. Which substitution? Whether electrophilic substitution or nucleophilic substitution. It is what? Nucleophilic substitution. OH minus nucleophile is substituting instead of chlorine, or by leaving chlorine. Alright, so your answer is substitution reaction. Next one, dear all of you, what is the IUPAC name of metacresol? In part 1 video, we discussed what is the common name, cresol. Cresol mean benzene with alcohol, OH group and methyl group. Benzene with alcohol and methyl group. If they are in the ortho position, that's called orthocresol, metacresol, paracresol. So we can see IUPAC name of metacresol. What is metacresol? Benzene is there with an alcohol and CH3 group should be there, okay? Then only it become cresol. Then what is mean by metacresol? Metacresol in the sense the CH3 group is on the meta position. Alright, so this is the compound called metacresol. Shall we write the IUPAC name? Okay, right. Here we have alcohol is there, methyl group is there. You know, as per the priority order of functional group, alcohol is the only functional group here, right? So number 1, number 2, number 3. Third position, you have a methyl group. Yes or no? Third position, you have a methyl group. So what's the name? 3-methyl. 3-methyl. What is the remaining species? Phenol. 3-methyl phenol. That is the IUPAC name of which one? Metacresol. So what's your answer? 3-methyl phenol. Option 4 is the correct answer. Alright here. So shall we go to the next question? Right. Next, again the IUPAC naming, let's discuss here. What is the IUPAC name of the given compound? Let me just read out the structure. CH3, CH, CH3 and we have OCH3. It's nothing but an ether. How to name an ether? So simple. Here we have, can you see this oxygen atom? Right, oxygen atom is there. Left side you can see there are total 3 carbon atom and right side only 1 carbon atom. So where is your parent chain? left. Which is your parent chain? Take a longest chain left side. This is the longest chain, right? Propane, propane, propane. Then the remaining species, you can take it as a branch. What is the remaining branch? Methyl group with oxy is called it as methoxy. Methoxy. Methyl group with oxy is called methoxy. Now, where is the position of this branch? Let's number the parent chain. 1, 2, 3, 1, 2, 3. Methoxy on second position. Alright. So second position methoxy propane. So what's the name? 2-methoxy. 2-methoxy propane. That is the IUPAC name of the given compound. Alright. 2-methoxy propane. What is your answer? Option number 2. 2-methoxy propane. Alright. So ether naming is important. Here we are going to the next question. Which of the following compound will react with sodium hydroxide solution in water? So the question, which of the following compound react with sodium hydroxide faster? You know, sodium, it's reacting, right? It's the upcoming species is what? Sodium hydroxide. So which of the following compound can react with the sodium faster? What's the meaning? The question whether the compounds are acidic or not, which is more acidic. If the compound is more acidic, it can react with the sodium or sodium hydroxide very fast. That's the meaning. So question number or option number 1, let me take the compound once again. You know, C6H5 and we have CH2OH. What is this compound? Benzyl, right? Benzene with the CH2 is called benzyl alcohol. And compound number 2 is given CH3-3COOH. That is nothing but tert-butyl alcohol. Tert-butyl alcohol. And what is option C or the third one? That is nothing but ethanol. CH3CH2OH. And what about the fourth compound? We have C6H5 phenol. The question is very clear. Which is more acidic in nature? Which is more acidic in nature? It can react with the sodium hydroxide or sodium compound, a metal, very fast. You know, let's discuss here. What is meant by an acid? You know, whether the compound is more reactive or more ready to donate the H plus ion or not. Yes, it can donate hydrogen or not. It can donate or these compound. Which species is ready to donate H plus ion faster? We can say that it is more acidic in nature. Correct. Which is more acidic in nature? Dear student, if it leave this hydrogen atom, you will get there is an anion. But this anion is not stable because this oxygen, see, that is not directly connected to benzene ring. It cannot make any resonance, not stable. So it cannot undergo or it is not a acidic one. Option number 2, this is a alkyl alcohol. You know, it is connected to which type of group? Electron donating group. You know, alkyl groups are electron donating group. Electron donating group will decrease the acidity. So this is less acidic in nature. Even compound number 3 contain electron donating group. It also having less acidity. What about phenol? We studied in part 1 video also. Phenol is more acidic in nature. Because when this hydrogen leaving as H plus ion, the remaining species is called phenoxide ion. It is highly stable due to resonance. So which is highly acidic in nature, that can react with the sodium metal or sodium hydroxide faster. So which is the most acidic one here? Let's go with option 4, phenol. Alright, here. Let me go to the next question. Phenol is less acidic than which compound? What is our master? The master compound is nothing but phenol. This is less acidic than which of the following compound? Option number 1 is given orthomethoxyphenol. Ortho position methoxy group. And second compound is given ethanol. Ethanol, CH3CH2OH. And third compound is orthomethylphenol. Alright, orthomethylphenol. And the fourth compound is given orthonitrophenol. Orthonitrophenol, right? Orthomethoxyphenol and ethanol, orthomethylphenol, and we have orthonitrophenol. What is the question? Here we have phenol is less acidic than. which means we have to identify in these 4 options which is the more acidic compound. That's a question, right? Let's find out. You know, this is phenol and this is methoxy group. Alkoxy, methoxy, ethoxy, all kind of groups are electron donating group. You know, electron donating group will decrease the acidity. So this is not the answer. Option number 2, this is a alkyl alcohol, right? Normal alcohol. When you consider phenol and alkyl alcohol, phenol is more stable due to the resonance stabilization of phenoxide ion. So this is less acidic than phenol. We need which is more acidic one. What about here? Methyl. Again alkyl. Alkyl groups are again electron donating group that will decrease the acidity. So this is not the answer. So I think the only answer possible, that is option 4, orthonitrophenol. Dear student, nitro group is a very strong electron withdrawing group. In the presence of an electron withdrawing group, acidity of the alcohol increases. So the question, phenol is less acidic than this compound because this is more acidic. So what's your answer? Question option number 4. Shall we go to the next one? Right. Which of the following is most acidic? Again, but different compound. Option number 1, cyclohexanol. This is called cyclohexanol. And what is compound number 2? Phenol. Alright. Phenol. And third one is metachlorophenol. Alright. Metachlorophenol. And fourth compound is what? Benzyl alcohol. Right. Benzyl. This is benzyl group with alcohol. Alright. Which is more acidic in nature? That's a question. What do you think? This is cyclohexanol, phenol. Definitely we can cancel first one because this is an alkyl alcohol. This is, you see that if you remove the hydrogen atom, resonance stabilization is there. Definitely we can cancel option number 1. And I think we can cancel option number 4 also because that is benzyl alcohol, right? If you remove this hydrogen as H plus ion, the remaining compound is not stable because that oxygen atom is not directly connected to benzene ring. It cannot make any resonance. So that's not possible. Either 2 or 3. Both of them having phenol, right? The second compound and third compound which contain phenol. Now what is the only difference? Chlorine is there. Chlorine is an electron donating group or withdrawing group. That is a electron withdrawing group. Chlorine is an electron. It's having a minus I effect, right? It's having a minus I effect. Chlorine is an electron withdrawing group. In the presence of an electron withdrawing group, acidity increases. So your answer is what? Third one. Greater acidity is for which of the following is most acidic? That is nothing but metachlorophenol. That's the answer. Okay. Option number 3. Here we have the next question. Again acidity but different compound. Mark the correct order of decreasing the order of acidic strength. Let me just name the compound one by one. Okay. What is the first compound? Phenol. What is the second compound? Para-nitrophenol. Third compound? Methoxy, right? Methoxyphenol. Meta-nitrophenol. Para-methoxyphenol. Alright? Okay. All of them contain phenol. You know, phenol is more acidic in nature. Alright? And only the difference is what, dear all of you? Nitro group, you know, it is an electron withdrawing group. Methoxy group, alkyl groups and alkoxy groups are electron donating group. Again nitro group, electron withdrawing group. Methoxy, it is an electron donating group. The theory, let me remind once again all of you, electron withdrawing group can increase the acidity and electron donating group can decrease the acidity. Just keep in mind. Let's go to the answer, dear all of you. Here we have, definitely I think you will say option B or option D, that is more acidic in nature because they contain electron withdrawing group. But the next confusion, this is para-nitrophenol, this is meta-nitrophenol. Which one having greater acidity? Correct. Just keep in mind what is the acidity order. What is the acidity order of orthonitrophenol, meta-nitrophenol and para-nitrophenol? The order is, just keep in mind, POM, POM, POM. Para greater, then ortho, then meta. Okay, what is the meaning? We're discussing about, this is phenol, para position nitro group, para nitrophenol, and next one is ortho nitrophenol, and the least acidic one is meta-nitrophenol. Keep in mind, all of you, acidity in the case of nitrophenol is para, ortho, meta in the decreasing order. So this is para, this is meta. Which one having greater acidity? Para. Para product having, para and ortho having more minus I effect compared to meta. That's why. Okay. So B having greater acidity. B having greater acidity, only one answer, that is option number 2. Let me check the others also. After B, definitely we can go to D because it contains electron withdrawing group. Okay, B over, C, D over. What about other? When you consider A, C, D, I will go with A, greater acidity, because C and D contain electron donating group. It will decrease the acidity. Alright, so A, B, D, A. Okay, A also over. And what about C and E? Among C and E compound, the order is just reverse with the electron withdrawing group. If an electron donating group present, its effect is more in when you consider meta and para product. Meta product having greater acidity than which one? Para. Therefore, C and then E. So option number 2 is the correct answer. So from the chapter alcohol, phenols and ether, the acidity based question is very important. Alright. Here I am going to the next question. Phenol can be distinguished from ethanol by the reaction with. You know phenol. What is phenol? Benzene with OH group. What is mean by ethanol? Ethanol means CH3, CH2OH. Alright. How you can distinguish? Through which chemical technique we can distinguish between these two compounds? This is phenol, this is ethanol. How you can distinguish them? Simple. Bromine water, you may study bromine water test and sodium neutral ferric chloride test. Which of the test, dear student? We can go with A and C. Here two answers are possible. You know, phenol, when it is treated with a neutral ferric chloride, neutral FeCl3, neutral ferric chloride, you may study it. It will form a violet colored complex. What is a complex? Fe3 plus is there, right? Fe3 plus will combine with which one? The phenoxide ion. The phenoxide ion. Phenoxide ion. 6 times and not balancing the reaction. Balancing the reaction. It will get 3 minus like that. This is the violet colored complex. Or keep in mind, when phenol treated with the neutral ferric chloride reagent, it will give you a violet colored complex. This is the only test given by mainly phenol. Other alcohols cannot give. What about bromine water test? You may study bromination process of phenol. Phenol, when you treated with the bromine water, what is happening, dear all of you? All the ortho para positions are occupied by bromine. What's the name? 2,4,6 tribromophenol. You may study what's the color of this compound. This is having a white colored compound. It's also given by phenol, not by ethanol. What about sodium? You know, both are actually acidic, right? Phenol and ethanol, both are acidic in nature. You know very well, this is more acidic. But sodium, you cannot use it to make a distinction between those two species because we can't identify through a reaction. Alright. So, phenol you can distinguish from other alcohol mainly through neutral ferric chloride and bromine water test. Next question here, all of you. Again, acidity. The increasing order of acidic strength of the following is, which is more acidic? Very simple. All of them contain phenol. So next you bothered about the substituent present on benzene ring. Here we have nitro group. Nitro group is an electron withdrawing group. Methyl group is an electron donating group. Methoxy group is also an electron donating group. Which is more acidic? First one. Because electron withdrawing, right? First one, greater acidity in option A and option B. So let me just cancel option C and D. And next confusion, this is more acidic in nature, whether second compound or third compound, which is more acidic. Dear all of you, the confusion is behind both are electron donating group. One is methyl group, one is methoxy group. Which is the strong donating group? I can say methoxy group is more donating group than methyl group. What dear? You know oxygen containing lone pair, right? Oxygen containing lone pair, right? It can donate electron. It is the best donating group. But CH3 not like that. It's a weak donating group. So methoxy group is a strong donating group. So what will happen? Acidity very less. Acidity very less. So third one having very least acidity. First one having more acidity. What is your answer? 1, 2, 3. Option B is the correct answer. Alright, option B. First one having electron withdrawing group, more acidic. Third one having very strong electron donating group, so very least acidic in nature. Option B is the correct answer. Here all of you, there is a simple question is providing for you. What is chemically Lucas reagent? You know Lucas reagent we are using to distinguish between primary, secondary, tertiary alcohol. You know studied tertiary alcohol will give immediate turbidity, secondary alcohol will give you turbidity after 5 minutes, primary alcohol only turbidity formed by heating. What is chemically Lucas reagent? You know very well, that is concentrated hydrochloric acid with anhydrous zinc chloride. This is called what? Lucas reagent. What is the option? HCl and zinc chloride. That is option D. HCl and zinc chloride. Keep in mind, concentrated HCl and anhydrous zinc chloride is the exact answer. Okay. Next one. Here we have among the following set of reactants, which one product is or produces anisole? What is chemically anisole, dear all of you? Benzene with OCH3. This is the aromatic ether. This ether is called what? Anisole. One methoxy group on benzene ring. One methoxy group on benzene ring is called anisole, right? Through which reaction you can prepare an anisole? That's a question. Let's carry out each and every step. First one. CH3CHO. Alright. CH3CHO reacting with RMgX. You know, we studied in part 1 video. This is your Grignard reagent, right? Alkyl magnesium halide. Any Grignard reagent, when you treat it with other than methanol aldehyde. Any Grignard reagent, when you treat it with aldehyde other than methanol. This is other than methanol, right? This is ethanol. Always you will get final product secondary alcohol. Secondary alcohol. Actually, this is not required here. This is ether preparation, not alcohol preparation. So, not option number 1. What is option number 2? C6H5OH. What is that? That's nothing but phenol. C6H5OH. That's nothing but phenol. First treating with NaOH. Alright. What will happen? Phenol is acidic in nature. So it will leave this hydrogen atom. The sodium is replacing the hydrogen. Correct or not? This H and OH eliminated as water. Sodium is a highly reactive metal. It can displace this hydrogen. So it will give you sodium phenoxide, NaO. Sodium phenoxide. Not over, they are treating with a CH3I, methyl iodide. You got the product right? What are the ions here? Na plus and phenoxide ion. What is ion here? Methyl plus and I minus. Just interchange double displacement to the phenoxide ion. O minus, what will attack? CH3 can attack. To the Na and I, that will be eliminated. Yes, this is your product, anisole. So let's go with option B. What about option C, dear all? This question we discussed, no. Phenol treated with a neutral ferric chloride, it will give you a violet colored complex, not our anisole. And what about this? This is called toluene. Toluene, when you treated with acetyl chloride or acyl chloride in presence of AlCl3, Friedel-Crafts acylation, not alkylation, acylation can take place. That will give you orthomethyl acetophenone and paramethyl acetophenone, not your anisole. So anisole means benzene with OCH3. It can be prepared only through the second method. First of all, phenol treating with the sodium hydroxide, sodium phenoxide. Then treated with the alkyl iodide, anisole. That's it. Next one, dear all of you, identify Z in the sequence of reaction. We have to find out the final product Z. Let's go. Your starting material is given. What is the starting material, dear all of you? It's given CH3, CH2, CH, double bond, CH2. What is the compound? But1ene. But1ene, first they are treated with HBr in presence of hydrogen peroxide. HBr contain H plus and Br minus. When you are adding a addendum or your adding species is HBr, when it contains positive and negative part, when you are adding into an unsymmetrical alkene, we have to follow anti-Markovnikov's rule because there is a peroxide. In the presence of peroxide, we have to follow anti-Markovnikov's rule. What is anti-Markovnikov rule? Negative part goes to the carbon with a more number of hydrogen. Positive goes to the carbon with a less number of hydrogen. So what is the product? CH3, CH2, CH2, single bond, CH2, Br. 1 butene converted to 1 bromobutane. Alright, this is your compound Y. Alright. Now, they are treated with a C2H5ONA. What is this compound? What is this compound, dear all of you? Sodium ethoxide. Sodium ethoxide. You know, this is a haloalkane. This is a haloalkane. This is sodium alkoxide. What is the reaction? Williamson synthesis. When a haloalkane treated with a sodium alkoxide, you can just write it like this. NaBr eliminated. Just add this group here. You will get the compound CH3, CH2, 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 here O, C2H5. This is your final product Z. You are getting a ether. Can you identify this answer anywhere? Option, shall we go with option A? Yes, option first one, CH3. Yeah, CH3. CH2 thrice, CH2, 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 oxygen. What is C2H5? CH2, CH3, right? Option 1 is the correct answer. Okay, next to go, we are discussing about a general question. The decreasing order of boiling point of primary, secondary, tertiary alcohol is. Okay, here they didn't specify which primary, secondary, tertiary. Of course, we have to consider an isomeric part. Let me give you a simplest example. I'm taking the compound CH3, CH2, CH2, CH2OH. What is the name of this compound here all? Butan-1-ol. It is a primary alcohol, right? Alright, it is a primary alcohol. Let me take the same molecular formula. With the same molecular formula, let me take another alcohol. This is what? This is again primary one, right? This is again primary. So let me make it to secondary because the question primary, secondary and tertiary. Okay, so we need a secondary alcohol. We need a secondary alcohol. So a secondary alcohol means, you know, OH group. OH group connected carbon should be connected to 2 carbon. Yeah, it is secondary. With the same formula, how we can draw a tertiary alcohol? Let's take tert-butyl alcohol. Right, this is the tert-butyl group with alcohol. Alright, so once again drawing here, tert-butyl alcohol. Tert-butyl alcohol. That is the compound tert-butyl and with alcohol. This is a tertiary alcohol. What do you think, dear student? Which one having greatest, question is boiling point, right? Boiling point. Which one having greatest boiling point? What we can say here, this compound having all the carbons are in the straight chain, more surface area, no branches. Therefore, primary having greatest boiling point. What about secondary? Branches come. You know, as branches generated, number of branching increases, boiling point decreases. Secondary. What about tertiary? Tertiary, so many branches are there, right? As the number of branching increases, boiling point of the hydrocarbon or alcohol, whatever, decreases. So, the order of boiling point is which one? Option A, primary greater than, secondary greater than, tertiary. Alright? I'm going to the next question, dear all of you. A simplest question. Which one of the following on oxidation gives a ketone? We studied that primary alcohol on oxidation we will get aldehyde. Secondary alcohol on oxidation we will get ketone. And tertiary alcohol on oxidation, tertiary alcohol will not undergo oxidation. Instead of that, it will give you alkene through which one? Dehydration, right? So which of the following on oxidation gives ketone? If you want to get ketone, we need a secondary alcohol. That is option number 2 is the correct one. Hope you clear that. Then the next question. In the following sequence of the reaction, what is the final product C? Let's carry out. Starting material is given CH3CHO, ethanol. It is reacting with the hydrogen in presence of palladium, reduction. Aldehyde on reduction, you will get primary alcohol. Why? We studied primary alcohol on oxidation, aldehyde. So aldehyde on reduction, primary alcohol. This is 2 carbon containing aldehyde. So what is the 2 carbon containing alcohol? Ethanol. Ethanol. This is your compound A. Let's continue. It is reacting with the sodium. Alcohols are acidic in nature. When it is reacting with the sodium, sodium can remove this hydrogen or displace this hydrogen. You will get CH3, CH2, ONA. Sodium ethoxide. Sodium ethoxide. This is your compound B. It is reacting with what? CH3I. Previous we discussed the same type of question. What is this? This is Williamson synthesis. When a haloalkane treated with the sodium alkoxide, sodium iodide is eliminated. Please add the CH3 group here. CH3, CH2, OCH3, this is the compound going to form. This is the formation of an ether through Williamson synthesis. So I think we no need the final compound or the name of the compound or the structure of the compound. We need only the functional group. What is the final product? That is an ether. What is compound C is the question. It is an ether, right? This is your compound C. Next question, dear of you, butan-2-ol is a primary, secondary or tertiary alcohol. What is butan-2-ol? There are 4 carbon atoms. Second position, there is an alcohol. CH3, CH2, CH3. This is called what? Butan-2-ol. Yes or no? It is a primary alcohol, secondary alcohol or tertiary alcohol? It's a secondary alcohol, right? Why? The OH connected carbon atom directly connected to 2 carbon atom. Therefore, it is a secondary alcohol. Option 2 is the correct answer. Hope you get it very fast. I'm going to the next question. The same type 1 question we discussed in part 1 video. Dear all of you, ethyl propanovate on reduction with lithium aluminium hydride gives. What is the product or the compound ethyl propanovate? It is an ester. How to draw the structure of ethyl propanovate, dear all of you? What is ethyl group? CH3, CH2, ethyl. Propanovate. What is propanoic acid? CH3, CH2, COOH. This is called propanoic acid, right? When it removes this hydrogen, then the species is called what? Which the ion is CH3, CH2, COO minus. This is called what? Propanovate. Propanovate. Right? Propanovate. Do you know when a alcohol, how you can prepare an ester? When a alcohol reacting with the carboxylic acid, water eliminating and the rings are fusing or the remaining chains are connecting, you will get an ester. How to prepare? This is ethyl. This ethyl, the first part represent in an ester, first part represent the alcohol part, second part represent the acid part, carboxylic acid. So alcohol is ethanol, from that we are getting the ethyl group. Your acid is propanoic acid, from that H gone, so water eliminated. So this group you attach. So here O, then CO, then CH2, CH3. This is the ester. Ethyl propanovate. This is the ester. This ester on reduction with a lithium aluminium hydride. Dear student, we studied in part 1 video. ester on reduction, you will get 2 alcohols. How to write the 2 alcohols? So easy. You know this oxygen atom, the single bonded oxygen. Left side, how many carbons are present? 2 carbon atom. What is the 2 carbon containing alcohol? Ethanol. Alright. CH3, CH2, OH plus. How many carbon right side of the oxygen atom? 1, 2, 3. What is the 3 carbon containing alcohol? Propanol. So your product is ready. Ester on reduction, you will get 2 alcohol. Here it is. One is ethanol, one is propanol. Ethanol and propanol. Option 2 is the correct answer. Clear all of you? Yes, here we are going to the question. The most acidic alcohol among the following. Compound number 1 is given methanol. Compound number 2 is given ethanol. Compound number 3 is given isopropyl. What is isopropyl group? A CH carbon connected to 2 CH3 is called isopropyl alcohol. What is terbutyl, dear all of you? This is called terbutyl alcohol. Alright. Question, which is more acidic in nature? Which is more acidic in nature? Can you say? All are alkyl group. Here no phenol, right? All are alkyl group. You can see there is an alkyl group here. These are a big alkyl chain is there. Here these are all alkyl groups. Here all are alkyl groups. You know, alkyl groups are generally electron donating group. All are electron donating groups connected to this OH group. We studied electron donating group can decrease the acidity of the alcohol. So, which one contain maximum number of electron donating group, dear all of you? Can you tell me? Which one contain maximum number of the electron donating group? Third one. So, this is very less acidic. Question, which is more acidic, right? This one contain 2 alkyl group, less acidic in nature. Here CH3, CH2 is there. Here only one CH3. So, which is the most acidic one? The first one. Methanol is more acidic than others. The theory is this only. If the number of electron donating group increases, acidity decreases. So, very less number of electron donating group only present in first compound. Therefore, it is more acidic. Alright. Here we are going to the last question, dear all of you. The question is given, the starting material is given ethanol. What is ethanol? CH3, CH2OH. This is the compound starting material ethanol. It is treated with phosphorus in presence of iodine. You know, what is the halogen we are adding here? Iodine. Addition of halogen in presence of phosphorus. That is halogenation. Correct. So, this alcohol will remove, iodine will substitute. We will get CH3, CH2 iodine. Ethanol converted into ethyl iodide. This is your product A. Not over. It is treated with magnesium in presence of dry ether. When a haloalkane treated with magnesium, you will get Grignard reagent. Correct? Grignard reagent. Where we want to add Mg between this carbon and iodine. We will get CH3, CH2, MgI. Ethyl magnesium iodide. This is your product B. It is treated with methanol. Methanol. We studied in part 1 video again. Any Grignard reagent, when you treated with methanol or formaldehyde, your final product always will be a primary alcohol. Alright. So how to write the product? That's also easy. Mg plus, what is the ions here? Mg plus and I, and this is the negative part, CH3, CH2 minus. This is the nucleophile. This nucleophile will come and attack to this carbon and this becomes O minus. Right? It becomes O minus. So I'm writing the product all of you. I'm starting here. CH3, CH2. Alright. Where it is attacking? On this carbon. This carbon having 2 hydrogen atom and this O becomes O minus. To this O minus, what will attack? This positive species will attack Mg plus and I. Alright, so I'm just breaking the bond here. This is the reactive part. Okay, this is your compound C. What is the last reaction? It is treating with the water, dear all of you. Water. Okay, it is treating with water. Okay, let's continue. It is treating with water. You know, water contain two ions. What are they? H plus and OH minus. You just add here to the O minus part, you can add H plus. So OH, alcohol is ready. To the Mg plus part, you can add OH minus. That is a byproduct. No need to bother about that. So what is the major product? CH3, CH2, CH2, OH. This is the product. What is the name of this compound, dear all of you? Propan 1-ol. Propan 1-ol. So what is the answer? They given, yeah, option fourth one, normal propanol. Normal propanol. Alright, dear all of you. So in part 1 and part 2 video for the chapter alcohol, phenols and ether, we completed most of the expected MCQ, most expected MCQ for your upcoming term 1 examination. So keep practicing. We will meet again with a lot of other chapter, with a lot of other most important MCQ. See you soon. Thank you all.